Hello everyone, my name is Priyanka Chaudhary and today's episode is all about flex your EMR cluster. Specifically with Graviton processor, how you can improve the performances. Today we're going to focus on those options. Let's start with our agenda today. So first, I'm going to give you the overview of Amazon EMR, and then we're going to go with the scaling options. What are the available options for scaling? And the third one is the performance, how you can improve the EMR performance with the multiple options we have in AWS. And then we're going to go with the little bit of how you can secure your cluster. And later on stages, I will be giving the demo of the small Spark job. So that is the plan for today. Hope to start the journey with everyone right now. So first of all, I want to focus on what are the situation in the AWS, how we are dealing with the modern data architecture. So modern data architecture is not dealing with only S3 data lake with the couple of services of analytics or data warehouses. Instead, we do have purpose-built databases, analytics services, open source services, machine learning. Everything can be integrated with AWS. And what are the benefits of using S3 as a data lake is, first of all, like a scalable data lake. So you don't have to worry about like how much data we can put it in a S3. It is unlimited. You can put as much as you can. It's easily scalable. You don't have to worry about how it will be integrated with the other services like purpose-built databases, machine learning services, or warehouse services. Number three is like it has a seamless data movement. So you can use some glue serverless where you can create a data pipeline and you can move the data between two services. And it's very seamless, and you can easily achieve your goals of integration between multiple ecosystem of AWS services. And the good thing about this whole data lake architecture, you can use a common service for unified data governance, which is called lake formation. And that is the key for doing the data governance piece over all the AWS related analytics and machine learning services. And the good thing about using the whole data architecture here, you don't have to worry about like performances. You can scale your EMR clusters. You can scale your other Redshift servers and everything very easily. And it's also cost effective. You don't have to worry about creating the clusters, maintaining the nodes. So today's focus is all about Amazon EMR. Let's transition it to Amazon EMR. So what is EMR here? So EMR is a cluster where you can run open source framework like Spark, Hive, Presto, HBase, and many more at one particular platform. You need to choose what services you want to use, and there you go. Like you don't have to maintain any cluster. You don't have to provide any node provisioning. You don't have to create any cluster tuning. So that's the way the Amazon EMR works here. And the good thing about using Amazon EMR is like you can use latest versions very easily. So we do have almost 21 open source projects which runs on Amazon EMR. And whenever any new versions comes for on those services, you can get those open source framework within 30 days. So that's the beauty of using Amazon EMR. So you don't have to worry about like what is running in the market. You can have those in EMR itself in within 30 days. The second thing is it's a best performance you can get it in EMR, that you can run your workload 2.4x faster as compared to any other open source. And also you have like couple of option, like you can use reserve instances, spot instances, and you can reduce the cost to 50 to 80%. And also whatever you are running on the workload, and you are paying for that. So it's a per second billing flexibility as well. And the beauty of using EMR is you can leverage S3 as a storage, and there you don't have to worry about like how you want to process the data securely, high performance with how you can scale the data basically, and you can separate segregate between compute and storage very easily. And also it's easy, it's scalable, no need of cluster provisioning, no need of any scaling mechanism to apply. You have managed scaling options and to suit your workload demand. So now let's go to what are the important frameworks you can run on Hadoop on EMR. So we have almost 21 open sources, as we already talked about, and we do have options that whenever any versions come newly in the market, you will have those versions available in 30 days of release. So that's the commitment AWS gives, that you do have latest versions of all the open source framework whenever available. Now let's focus on what is the EMR cluster architecture. EMR cluster is consisting of basically three in type of instances. One is the master node. Master node has all the basically name nodes, HDFS, resource manager. The whole coordination will happen there. All the cluster related master things will be happening on the master nodes. And the good thing about using EMR master nodes that it's not a single point failure. Instead, you can put like a three. You can scale up to you can scale your master instance to 3. So in case of any failure with the one instance, it will be switched to the next instance, and your cluster will stay active. So there is no single point of failure. You can have up to 3 nodes in the master. And so next point is like we do have core nodes, which you can add and remove gracefully, absolutely. And you can use it for increase the compute capacity. Here you have data nodes, node managers, and you have worker nodes specifically. So basically, we always advise our customer to use on-demand and a mix of on-demand and spot instances in core nodes, so that they can have a benefit of using spot instances, which is cost effective. And we're going to cover those in our future slides. Number 3 is the task nodes. These are completely optional to increase the compute capacity. So you have node manager, yarn, worker. So you can definitely you want to have the more compute capacity, you can use it. Otherwise, you can leave it also. And generally, for the customers, what we recommend, you can use spot instances for task nodes, because it will not break your cluster. It can tolerate loss of task nodes. Cluster can tolerate loss of task nodes. So this is the whole EMR cluster where we have all 3 type of instance groups. So why in the journey of EMR, why it is important, and what are the compute flexibility? Since we're talking about flexing your EMR cluster, we do have multiple options of instance groups. So basically, if you want to choose general purpose is specifically if you have batch processes, simple workloads which you want to run, so you can go with the M family. If you have compute intensive workloads like machine learning, then you can go with the compute intensive, means C family can be used. If you have memory intensive workloads, supposedly for interactive analysis, any complex analysis, then you can go with X1 and R4. And similarly, we do have storage intensive as well, where you want to have like large HDFS cluster, and you can go with D2 and I3. All those families are available in EC2. You can choose it. You can you can try and test which workload is better for you, and you can choose your instance according to that. And similarly, if you can see, we do have some Graviton processor instances as well, just like M6G, C6G, and R6G. These instances are has Graviton processor, and which provides you better performance, and with the less cost as well. We're going to discuss those Graviton processor in future slides. Let's go to the next one. The good thing about using EMR is we can use Amazon S3 as your persistent data store. What is the benefit of using Amazon S3 as a persistent data store? That you can reduce the cost by using transient cluster. Now let's discuss what is the difference between our long running and transient cluster. Long running cluster is the one where you have this workloads are running, and if the workloads are completed, the cluster is still running, and it is not it is definitely, we recommend to the customers, if you have critical workloads and where you and it is like ongoing workloads where you cannot beat any SLA related problems, then you should go with the mission critical clusters. You should go with the long running cluster. But if you have some clusters like if you have workload like which completes in the night itself, and which have like a few hours of the buffer that you can bear, then you should go with transient cluster. So the way of using transient cluster is like you can decouple between storage and compute. So you can run your transient cluster EMR cluster with Amazon EC2 Spot instances. You can have multiple and heterogeneous analysis cluster, and service can use the same data. So basically all the data will be served in Amazon S3. So whenever the cluster starts, it will take the input from S3, it will process the data, and it will produce the output in the S3 back. And workload, once the workload is complete, it can go to termination. So you can reduce the cost definitely a lot with the transient cluster option. And the good thing about using transient cluster is if you have five different workloads, you can run those workloads in parallel, and you can use the capacity what is needed in each cluster and utilize it in a better way. And since S3 offers 99.99 12 times 9 durability, so it's a good option to leverage EMR with the EMRFS. Now let's go with what are the deployment options available for EMR. Number one is, it's very common, Amazon EMR on Amazon EC2, which we are talking about that today. And second one is the Amazon EMR and Amazon EKS. Now we do have option that you can run your Kubernetes Amazon EKS is the Elastic Kubernetes services. You can run it on EMR as well. And another one is AWS Outpost, which is very commonly used for the government cloud. So if you have the requirement of using AWS Outpost with the EMR, you can utilize that also. And this option is pretty new, which was announced in the last free event, Amazon EMR serverless. So you do have a benefit of that. You don't want to manage any cluster, then you can go with this option as well. So these are the deployment app options available in EMR. Now let's go with our next section, which is called Amazon EMR scaling. Let's see how flexible you can make your cluster and how you can utilize best out of it. We do have two options to go over the scaling piece. So we do have Amazon managed scaling and the auto scaling. Managed scaling is the one which is completely managed by EMR itself. It's an algorithm which constantly improves, giving all customer benefit out of the box. And auto scaling, it's an old way, tradition way to do the metrics and create the scaling on top of it. So definitely, it's a completely different type of scaling we are talking about. In auto scaling, you have to invest more time. It's a manual mode. You need to create the metrics on CPU, memory, and on basis of that, you can decide how many instances will scale up, how the scale up will happen. But in managed scaling, you just need to mention what is the min and max you want. Suppose I have a requirement of going with 5 nodes, and when I have like a critical workload is going on, and whenever the workload is complete, I can have 2 nodes or something. So I can explain minimum of 2 and maximum of 5, and you can put that way, and then rest is all taken care by Amazon EMR itself. But in here, you need to define all the configurations, all the metrics. So you can utilize any of this option to have scaling. The minimum EMR release versions are 5.3.0, 5.30.1 plus is for managed scaling, and 6.1.0 plus is for managed scaling, and auto scaling can happen on 4.0 plus as well. And the good thing about using managed scaling is it is collecting the metrics every 1 to 5 seconds. So meaning, if your cluster is seeing lots of workload, and you have defined the max capacity of maybe 100, then it will go to 100 nodes very quickly. So the action time and the metric collection time is better in managed scaling. And auto scaling, it takes like every 5 minutes, so maybe you will see a little bit of delay. So the scaling algorithm which is following by managed scaling is the dynamic target scaling, which it follows the dynamic strategy and compute the actual cluster and see the requirement of scale up and scale down. And this both happen for scale up and scale down scenario. But in auto scaling, it will be a stepped scaling. So meaning, like if you need 5 instances, so it will go one by one. So it's a step scaling basically. The cooldown period between resizes for managed scaling is almost negligible, and you will see the changes happening very quickly. But in auto scaling, it takes time. It has some cooldown period. But the if you want to go with the DIY type of metrics, definitely auto scaling is the better option. But if you want to rely on Amazon managed algorithm, then managed scaling is way to go. Sorry. So what are the main features we talked about in managed scaling is, number one, there is no need of any configuration. Just provide what is minimum number of instance and maximum number of instance according to your cost constraint, and that's it. You can use this managed scaling appropriately. The second one is more data points and faster reaction time. As we already talked about, it takes like 1 to 5 seconds basically to grab the metrics and act upon it. So it means it is always faster. It will act upon the auto scaling feature really faster. And you can save up to 20 to 60% cost depending upon the workload pattern. And the good thing about using managed scaling is, since the metrics we are taking like very frequently, so it will be high resolution for managed scaling. But if you have a specific option that if you want to go with DIY type of scaling, definitely auto scaling is the better option. So managed scaling is completely managed option. What is the benefit of using managed scaling? As we already talked about, it reduces the cost by up to 60%. It's completely managed, auto scaling and cluster. No configurations required here. More data points and faster reaction time. Cost reduction of 20 to 60% depending upon workload patterns. So these are the benefit of using managed scaling, and you can flex your cluster with these two types of scaling very easily. Now let's go with the what are the key options we can have with the cost optimization. Cost optimization is really important nowadays because we don't want to spend a lot of money on standing the EMR cluster. So what are the main options you have for cost optimization? Number one is transient clusters. Number two is reserve instances, and number three is spot instances, instance fleet. Let's go one by one. Transient cluster is, as I already explained in previous slides, you can run the cluster for the time whenever your workload is running, and once the workload is complete, you can auto terminate it. That's it. You can save your money out of that. But if you have a plan that if you are using long running clusters and you have planned to use it for many more years, like 4 years, 2 years, we do have some offering for reserve instances, which where you can pay less as compared to on demand instances. And the third option is a really common option, which is being used by customers, is spot instance and instance fleets. Spot instances are those which can be reclaimed by AWS team with the 5 minutes of notification. But for instance fleets, you can have mix of many type of instance there, and so that in case AWS reclaims one of the instance, then you have second instance stand up to cover your compute requirement. So these are the main three options where you can save your money while using EMR cluster. So what are the benefits of using EC2 Spot instances? Number one is like you can have 90% discount over on-demand price. So you are paying really, really low when you are choosing Spot instance. We do have a caveat that you can lose that instance whenever AWS wants to reclaim, but we can organize those instances in a way that there will be no actual loss to you. So we can talk about it in our later slides, how you can plan your instances in a way that there will be no loss to the data. The second one is you can produce faster results. So by using maximum capacity, you can leverage those Spot instances and you can complete your workload faster than with the whatever budget you have. So you have 10x while staying in the budget, to be exact. And it's easy to use. It's just need a configuration. Okay, what I needed for instance fleet, and you can leverage that very easily with ECS, EKH, and even for the third parties as well. So what are the benefits of EMR with this Spot instance? Number one is accelerate compute. Definitely, this is the better option for running multiple tasks on parallel with this instant type. You can reduce cost, which we already discussed, like 90% of discount versus on demand. And this third one is you can quickly ramp up with the massive data jobs. So you can run maybe like millions of records with the help of Spot instances, and you can increase the capacity of your EMR cluster. So it's definitely scaling is really easy by using Spot instances. So as we discussed about instance fleet, why we talked like Spot instances are perfect for instance fleet? Because so generally what we prefer to the customer that it can be configured for a mix of on-demand and Spot instances, so that once the high capacity is needed, you can have those Spot instances at low price. And if Spot instance is in task mode and reclaim, another instance is there. So you are covered with so there will be no data loss, and you can cover with the other instance as well. So these are the perfect for EMR instance fleet. So the some of the recommendations which we already give it to customers is like you should have mix of different instance type in one group. Second one is you should have on demand and Spot instance in one group, so that you, in case the Spot instance is gone, still you have on demand instance to cover up the whatever is needed for that workload. So it's not like complete data loss at all. And each instance can have different EBS volume size, so you can choose it like which option is better for you during the Spot by using the Spot instances. You can choose the total capacity that you want, and you can divide, okay, how many instances needed, and you can diversify like which instance type will be good for this workload. And good thing about using Spot instances is like you can use which availability zone has the cheapest option, and you can utilize that for your cluster, and that will make your cost even lower than whatever you were expecting. You can enable to capacity optimize allocation strategy, and you can template this configuration and you can reuse it for your other workloads as well. So we do have some recommendations. I think these are the recommendations which customers are using and getting success in reducing the cost and getting the work done and faster performance. So generally, this is a mix of on-demand and Spot instances we provided to the customers. So if we have like three types of node: leader node, core nodes, and task node, and you have long-running clusters and data warehouses, so definitely, because it is a critical loads, so definitely on-demand is preferable for the leader node. But for core node, it can go with on-demand and instance fleet mix. And for the task mode, definitely Spot and instance fleet mix. So because task nodes can be, if it is gone, there is no problem. But for core node, you should have some compute capacity left. If you have some production load where there is no SLA and it is cost driven, definitely you can go with Spot instances for all three nodes. For data critical workloads, we definitely recommend that you should have on demand instances and core nodes with the on demands, and the task node should be spot or instant fleet mix. For definitely for the QA environment and lower environment, you can go with smart instances because it will definitely bring the cost down by using smart instances. So this is the common scenario which we presented to customers so that you can utilize the spot instance in a better way without any data loss. There are two cases which we have for customers. Basically, Salesforce is using like a 75, and they save up to say 75% to 90% on compute with Spot instances. So the good thing about like even some of the customers has recognized it, and Salesforce is the one of them, and they observe an increase in initiative job performance and saved up to 80% versus on demand pricing. So meaning like it's actually working with the customer with which they are where the due diligence is going on with the which spot instance can go with the workload. Similarly, we do have another customer, Zillow, where we can see like they are using automatically scale up, scale down, provisioning hundred of thousand of nodes, using the mix of on demand and spot instances, and they are getting like better results by running EMR across on demand and spot instances, and they can scale down across the instance groups. Now let's go with the what are the performance option, since this is a part of a series of a Graviton. So let's talk about how Graviton is helping the customers with the performance. So there are differentiated performance on Spark, Presto, and HBase. So basically, we noticed that in our Amazon EMR, this Apache Spark 3.0 is 2x faster than TPC DS 3TB benchmark. And this is the observation we have with the multiple testing, and definitely for the Presto also we saw 2.6x faster results. And the good thing about Amazon EMR, they do have a Graviton 2 processor, which is actually bringing the performance improvement, which is like additional 11% at 20% reduced cost. And also this is like complete 100% open source API compliance, since we are using open source framework over here. So definitely you can improve the performance by using EMR in EMR with the Spark 3.0, Presto 0.238, and with the Graviton 2 processor, and get the better performance out of that. So here we're going to talk about how AWS Graviton instance is coming up. So it has a best price performance within their instance family. So we did some analysis, and we do have a blog on that as well. So if we are comparing the output of M5 versus M6 using 5.301 and TPS DS3 TB benchmark queries, you will see 12 to 16% improvement in the performance compared to M5 instance family. And there is a very 20% lower cost as well with the Graviton 2 processor, and up to 30% better price performances as well. So this is a graph which we ported on price versus performance improvement range by instance family. So you can see the difference between C5 and C6G. So definitely there is a difference between, and the performance and price versus performance is better for the Graviton 2 processor, and we are seeing it as in a graph. Let's go with another next section, which is our last section for today, like EMR security, which is pretty important. So every customer, whenever they want to move their Hadoop ecosystem to EMR, many questions comes up like, okay, how I'm gonna go for the isolation virtual network, how I'm gonna authenticate, who am I, how I'm gonna do authorization, how the data protection will happen, how I can do the auditing. So let's answer those questions with this slide. So for isolation purpose, you can utilize virtual private cloud, which is called Amazon VPC, where you can define your public and private subnets. And there you can define like which IP address you want to use for your EMR cluster going forward. For authentication purposes, we do have Linux user create. You can create Linux user. Public keys can be created, and Kerberos, it's very common nowadays. Like customer is going with the Kerberos method, where you can authenticate on the basis of Kerberos tickets, where you can have like key tab files for the customers to be created and use it for authentication. The third one is authorization. So we do have for HDFS specifically, we can use POI6 based authorization methods. So you can authorize your HDFS related queries with the POI6 based authorization. And data protection is promised for EMR. You can utilize encryption at rest and encryption in transit. And for auditing purposes, we do have log analysis using CloudWatch, or you can have logging enabled with the EMR. So these are the some of the methods where you can do the security on EMR Hadoop with the EMR. So once the customer is moving to EMR, you can submit your workload with the help of EMR steps, and you can control those EMR steps using IAM principles. You can submit units of work EMR cluster using the steps API. You can use direct connectivity to the cluster. It's not necessary to submit work in this fashion. So definitely it will run with the Hadoop super user, but you can authenticate with the help of IAM principles. And for node level, you can go with the IAM, which can handle EC2 session manager to start the console. So using the public key is not recommended nowadays. You should go with the EC2 session manager so that you can authenticate with the help of IAM. And your data scientist and team can go with the EMR notebooks, which is like Jupyter notebook for the EMR console, and submit their jobs to EMR cluster. So these are the very common ways which we are using IAM credentials or assuming a role using federated access. What are the common data authorization options are available? For storage based, for EMRFS roles, user roles, mapper. For HDFS, you can leverage POI6 based policies. For Hive servers too and Presto or HBase, you can use SQL based authorization. So you can create a user on SQL and authenticate there. And for fine grain access control, or you can use like Apache Ranger, or AWS Lake Formation is very common for fine grain access control. So these are the pretty common methods which we use for data authorizations. So this is like a last slide of this episode. Like you can have data protection using encryption in transit and encryption in rest. So how things work over here when you have data at rest. So for cluster node, you can have EC2 instances has EBS volume where you can encrypt the data, and for open source HDFS, you can use LUKS encryption, which will be only applicable for root volume. But for in transit, there are two methods are there. So if you're connecting between EMR with the S3 can have KMS encryption, and traffic method can be controlled with TLS encryption. So there you can control the data encryption with that. For distributed application, open source encryption functionality you can leverage. And definitely for S3, you do have option of SSE S3, SSE KMS, CSE KMS. So whole of the data can be encrypted with the help of EBS encryption, EMRFS encryption, LUKS encryption, TLS encryption, and everything will be covered with that. Okay, so now let's go with our demo, which will be where I'm going to showcase like how the cluster settings can be configured, and how we can set up auto scaling, and then we'll go with our Q&A. That's the last sector of the this episode. Thank you. Okay, let's start with the EMR demo, how we can create the cluster, how we can configure it with the auto scaling options. So let's go with the search button over here and go with the EMR. Now we are on EMR screen. You can see one of the cluster is running, but let's create a new one here. We can put a name. We should go with the go to advanced option, so you can see how much configuration and what kind of open source tool you can utilize over here. So here I'm choosing like 5.3.6, which is the latest one in the 5 series, and I'm choosing Hadoop as my cluster, Hadoop as my open source framework, and the Hive and the Spark. I want the Spark as well. So where is the Spark here? There you go. Here you have an option, as I already explained, about fault tolerance for master nodes. So you can choose this option to go over, like if you want to go with the 3 master nodes for fault tolerance for master node or leader node. So since it is just for demo, I'm not utilizing it as of now, but you can utilize it for sure for the production workload. So there is no single point failure. Choosing this option, you can leverage Hive metadata outside of this EMR with the glue catalog, or Spark table metadata as well. So it's up to you. If you're using something which is like not an EMR, you want to leverage Hive table metadata, you can utilize these options as well for that. There are options that you can do some configurations, like you can change the HDFS files, and all the configuration is needed for your particular cluster. You can edit your software setting over here. Since I'm not working for the production cluster, I'm not utilizing this option. Here we do have steps options. Steps option is one, like you don't have to go to OS level for running any job. You can submit it directly from the EMR steps. I will showcase like how you can do it, and for that you can choose how many steps can go in parallel, and you can go with 2 to 256 6 steps to be exact. So if you want to run 10 steps in parallel, you can utilize that, and it will give the better results, because you're running multiple workloads in parallel. And similarly, you do have these are the 2 options are there for the termination, which is for transient clusters and for the long running cluster. So this first option is for the long running cluster. If you want to keep the cluster in the waiting state, so it can stay like that, it will not auto terminate. But if you want to use with the transient cluster, then you should choose this option, which is cluster auto terminate. So means after step is complete, you can terminate that cluster. And here you can choose what kind of step you want to submit. It could be streaming program, high program, pick program, or any custom ZAR file you want to choose. And let's go to next screen. Here you can define what are the cluster configuration. We do have 2 options of using instance, like a uniform instance group, where you can utilize same instance type and purchase option for each node type. Or you can have this option, which is instance fleets, which is very popular, and it can reduce a lot of cost, which we already talked about in our previous slides. So you can utilize that, and you can have multiple option with spot instances and on demand. Since it's a production, it's for demo purpose, I'm using uniform instance group, but you do have option to mix and match and purchase options for your instance group. Here you can define which VPC network we have. So I do have a default VPC and the project VPC. I'm using project VPC. And since I want my cluster to be in private subnet, I can utilize this US East 1A. Here you can define how many instances you want. So if you have checked the multi-instance for masternode, so you can see it will come up as 3 for you. But since I have not checked that for masternode, since it is for demo, so you can see only 1 instance is there. But you can choose whether you want on demand or a spot instance for the non-critical workloads. And core, you can go with the 0 to whatever you want. And for the spot, so you can utilize on demand or spot instances over here for that purpose. Task instance group, you can have multiple options. You can keep like 5 or 4 task group, so that you can have some of the task group with the spot and some of the task group with the on demand, so that once the utilization is done, once the workload is complete, you can leave, you can remove this task group altogether, and there will be no problem. And since we're talking about Graviton here also, so you do have option to choose Graviton processor here. So let's choose one from the Graviton itself. Let's see, we do have M5G. What is that one? Yeah, let's choose this M6G or anything. You can choose the Graviton processor, and it will reduce the cost as well, and it will be providing the better performance. So here in the cluster slash scaling, we talked about like a managed scaling. You can choose what scaling you want. Number one is EMR managed scaling, and the second one is auto scaling. In managed scaling, if you choose this one, you will have option of, okay, how many instances you need minimum and how many instances you need maximum, how many can go with the on demand, and how many core nodes you needed. So you can define this setting. So let's enable this. And if you want to go with the automatic scaling option, then you need to provide all the details by yourself. So it's not like a auto control, it will be controlled by you. Since we are more interested in going with the managed scaling, I'm giving you demo for the managed scaling option. Here you can terminate your cluster maybe for how many hours you want, like maybe 24 hours, 13 hours, or whatever. So whenever it is idle, it can enable auto termination. It will not terminate the cluster if the cluster is busy, but if it is free and free for like 1 hour, you can do this setting as well. It will definitely help you reduction of the cost. Here you can manage what EBS root volume you need. Since we are going with the EMRFS as well, so I'm going to keep it very low for 10 GB. But if you have a requirement that you want root volume to be more, you can select that option as well. And then once this is selected, you can enable logging, which can be done in the S3 folder. You can do log encryption as well with the key. You can provide KMS key ARN. Debugging can be enabled as well, and termination protection will help just in case someone try to terminate it. You can, if you have a production cluster and long running cluster, you want to keep it like that, then you can use this option so that there will be no by mistake termination happen here. And you can tag your cluster with the whatever option we have. Since we are doing the demo, let's give demo as a. So you can use consistent view for EMRFS because S3 is the eventual consistency, but you can use strong consistency as well, and you can use it with the EMRFS option. And you can mention which release Linux version you want, if you have something in mind, which AMI ID do you have in your mind, you can choose that AMI ID and select that as well. For bootstrap action, if you want to configure some software whenever the cluster is ready, you can configure that with the bootstrap steps. So let's do that. And after that, you can select what key pair we want. And we can create some IAM roles, permissions of our choices, like what is needed and what is not. Just like I do have EMR EC2 instance profile, which can enable SSM session manager. And I do have EMR default role, which can go with the S3 reading policy applied as well. And here in the security configuration, you can mention which KMS key, which encryption key you want. We can create one security configuration for Kerberos also. So all the security related things you can configure over here. And we do have option of creating a security configuration separately also, and you can utilize it later on. Security groups are for who can access this, maybe which ports you want to enable for master, core, nodes, and the service access. So these are the options which we need to do to create the cluster. And once you are satisfied with everything, then you can see like cluster will start. So in respect of the time, I'll not wait for the cluster to be started. So let's go with the one which I already have working. So here I am going with the in my cluster, I do have two open source frameworks, Spark and Hive. And let's go to the master node, and I want to run my one small Spark jobs, which will convert my TSV file to Parquet. So let's go with this, and this is like on demand. One second. This is the master node. Let's go with this one. So here we go. So this is the EC2 instance which we have, and this is M6G X large, which is definitely, this is one of the Graviton processor with the instance we have. Let's connect that. And since I'm not following like a SSH public key method, I'm using session manager. So let's connect that instance. And I'll be using that I'll be using this particular user as a Hadoop, so that I can run all the jobs here. Let's go to TMP, and I do have a script ready here, demo.py, which I have already planned it for this particular session. So let's see what is there in that. So what I'm doing, like I'm grabbing, creating Spark context Spark session, and I'm reading one S3 file with the csv.csv option and writing it to the S3 bucket in this account and with the Parquet format. So that's what I'm doing. So let's try to run this job and see how the things are moving. So I'm gonna do Spark submit. And then this is our job, demo.py. So let's put the name demo.py. So it's running in the local mode. You can use the cluster mode as well, but this this thing is started already. Let's see. We do have our S3 bucket. Let's go to S3 bucket as well. So these are the schemas which I have printed just for the sake of this demo. And then let's go to S3 bucket, where we're gonna keep the final output and the Parquet format. So here you will see there is a bucket for this particular webinar. There is no data as of now, and I'm expecting once the job is completed, we will have the data available there. So let's see. Okay, the file is here. This file has been created just now at 12, just now for as part of this demo. So that's it. So you can run this any kind of Spark job with this EMR, and you can configure it according to your choice, scale it according to your choice. This is a small demo for this as part of this presentation. Now since we are end of this session, let's go with the Q&A. Any questions we have, we are most welcome here. Thank you.